In today's lesson, we'll be learning about conjectures and counterexamples. As mentioned in a previous lesson, a conjecture is a mathematical statement that hasn't been proven true yet. In other words, it is an educated guess. Meanwhile, a counterexample is an example that disproves a statement. Our first conjecture states that a right bisector in any triangle will always pass through a vertex. Let's go over some key terms. Right, in a mathematical sense, refers to a 90-degree angle, whereas bisector refers to cutting something in half. This is related to a midpoint, which we learned in a previous lesson. Meanwhile, a vertex is just another way of saying a corner. Take a minute to think about this statement. Could it be true or could it be false? Our conjecture stated that a right bisector in any triangle will always pass through a vertex. Let's begin by drawing a right bisector in a triangle. I'm going to draw a triangle that appears to be an equilateral triangle. As mentioned beforehand, bisector refers to a midpoint. So I'm going to draw a midpoint over here, and I'm going to indicate that with these symbols. Next, the term right refers to a 90-degree angle. So what I'm going to do is I'm going to draw a line going through our midpoint at a 90-degree angle. This blue line is a right bisector. As you can see, it does pass through a vertex, the vertex being right over there. I'm going to do the exact same thing in a different triangle. This time, I'm going to use a right triangle. So, a midpoint would be right over there. I'm going to indicate that with these symbols. Next, I'm going to be drawing a line going through the midpoint at a 90-degree angle. As you can clearly see, this right bisector does not pass through a vertex, which makes this a counterexample to that statement. Therefore, the conjecture is false. A right bisector in any triangle will not always pass through a vertex. It does sometimes, but not always. Our second conjecture states that a median will bisect the right angle in all right triangles. There are some key terms to pay attention to. A median refers to a line segment that goes from a midpoint to a vertex, while bisect the right angle means cut a right angle in half, meaning that 90-degree angle now is cut up into two 45-degree angles. Take a minute to think about this conjecture. Could it be true or could it be false? Our conjecture stated that a median will bisect the right angle in all right triangles. Let's begin by drawing some right triangles. I have a right triangle over here. Now, I'm going to draw a median. A median begins at a midpoint and it goes to a vertex. If I were to use a protractor, that would end up to be 45 degrees, and this would also end up to be 45 degrees. Therefore, this median does bisect this right angle. Let's look at another right triangle. Again, I'm going to construct a midpoint right over here, and I'm going to draw a median from this midpoint to that vertex. Again, if you take a protractor, that angle would measure to 45 degrees, and this angle would measure to 45 degrees as well. Therefore, this median does bisect the right angle. Let's take a look at a third right triangle. Again, I'm going to construct a midpoint right over here, and I'm going to construct a median starting from that midpoint to the vertex over there. Again, if you were to use a protractor and measure this, that would be 45 degrees, and that would also be 45 degrees. Therefore, that median does bisect the right angle. At this point, I think it is safe to make a conclusion. Therefore, the conjecture is true, since we cannot think of any counterexamples for this statement.